This is for 11 methods. We're going to look at exercise 2C, question 9 and question 11. Okay, so for question 9, we want to write in form y equals mx plus c, given the gradient and a point that passes on the line. Okay, so for 9a, I know that the general equation for the line is y equals mx plus c. Okay. I need to know my gradient and I need to know my y-intercepts. Okay, how do I get my gradient? Well, I know that the gradient's 2, so I can substitute 2 in straight away. What I don't know is my y-intercept. So how do I get it? You sub in a point that passes through the line. So you sub in when x equals -4, y equals to -1. When x equals -1, y equals to 4. So I sub that into my equation. So I sub into this equation, not the top one, because we already know the gradient. So when y equals 4, I replace y with 4. My x value is -1. So I'm subbing -1 plus c. And I solve for c. So that's 4 equals -2 plus c. I add 2 to both sides to get rid of the 2 here. So I get 6 equals to c. So therefore, your equation of the line would be y equals 2x plus 6. And you're done. Okay, so because you have your gradient and your y-intercept. For 9c, you go through the same process. Y equals mx plus c. I know my gradient happens to be -5, and I need to solve for c. So I sub in 3, 0. Okay, when y is 0, x is 3. Okay, so this is -15 plus c. I get rid of 15 on both sides, so I add 15 on both sides. So there's 15 on this side now. The 15, if I add 15 to the other side, there's -15 and 15 cancel. So left with c equals 15. So therefore, y equals -5x plus, not plus, minus 15. Okay, that's your final equation. Okay. Now, next question, question 11. I want to do the same thing. Okay, except the only difference between question 9 and question 11 is question 9 actually gave you a gradient. Okay, so it made your life a bit easier, right? They were given to you. They handed the gradient to you. In question 11, we don't have that luxury. We actually have to find a gradient. So we have to use a formula. M equals y2 minus y1 over x2 minus x1. So let's apply this to C first, question C. So I've got y2, 3 minus 0 over 3 minus 3. Okay, so that's 3 over 3 plus 3, which is 6. That simplifies to a half. Okay. Now, I have my gradient y equals mx plus c, general equation of a line. I sub in what I know already, so I know my gradient's a half. Sub in a half. I need to substitute another point in, which the line passes, to work out c. So you can sub in either -3, 0 or 3, 3. So you can either sub in that or that. No problem. Both will get the same answer. You can check it for yourself even. Now I'm going to sub in -3, 0 because it looks nicer. So when y is 0, x equals -3. Okay, let's simplify this. A third of -3 is -1 plus c. So if I move the 1 to the other side, I get c equals +1. So therefore, your equation is y equals a half x plus 1. Okay, and you're done. For E, you go for the same process. My gradient is 8 minus 2 over 4.5 minus 1.5. So 8 minus 2 is 6. 4.5 minus, so 4.5 plus 1.5 is 6. The gradient's 1. Oh, that's nice. So y equals mx plus c. I know my gradient is 1, so I'm just going to I'll replace the m with 1, and then I substitute one of the points in. While both points aren't that nice, I might sub in 4.5 and 8. Okay, so I'm sub in 4.5 and 8. When y is 8, x equals 4.5 plus c. Now I subtract 4.5 from both sides, so I'm left with 3.5 equals c. Now, Your final equation would be y equals mx, so 1x plus 3.5. Now, another way to write 3.5, I'm not sure if the book did this, is 7 on 2. Okay, so it's the same thing. So hopefully that helps.